Now moving forward, let's consider another question, that is question number 5 from section B. Let Bi, I is 1, 2, 3, be 3 independent events. Clear on that? So these are 3 independent events in a sample space. The probability that B1 occurs is alpha, only B2 occurs is beta, only B3 occurs is gamma. So only B1, that's alpha, only B2, that's beta, only B3, that's gamma. Let P be the probability that none of the events B1, B2, B3 occur. So P is the probability that none occurs. Correct? Now, and these 4 probabilities satisfy the equations alpha minus 2 beta into P is equal to alpha beta, and beta minus 3 gamma into P is equal to 2 beta gamma. All the probabilities are assumed to lie in the interval 0 to 1. We have to find the value of P B1 upon P B3. Let's try. Suppose P B1 is X, P B2 is Y, and P B3 is Z. Let's consider the 3 events. Now the probabilities. Now question says that only B1 occurs. Only B1 occurs, this is alpha. So alpha is equal to B1 occurs, B2 does not occur, B3 does not occur. Clear? Similarly, beta is 1 minus X into Y into 1 minus Z. Gamma is 1 minus X, 1 minus Y into Z, and P is 1 minus X, 1 minus Y, 1 minus Z. Clear on this part? All right. Now we have to talk about P B1 upon P B3. That means we have to find X upon Z. So let's focus on these 2 terms. When you say this value alpha and this value P, when you divide the 2, you will see that 1 minus Y, 1 minus Z will be cancelled. So here we have alpha by P is equal to X upon 1 minus X. Just cross multiply. This gives you alpha minus alpha X is equal to Px, or simply X is obtained here as alpha upon P plus alpha. Similarly, you can find Z. Obviously, it would be on the similar lines. Z will be gamma upon P plus gamma. Correct? Now, what the question is asking for? X by Z. Let's write down. Therefore, probability of B1 upon probability of B3 is equal to X by Z, and this is equal to alpha upon P plus alpha multiplied by, you can put P plus gamma in numerator and gamma in denominator. Right? So this is what we are looking for. Now, if you look at the given another constraint which says that alpha minus 2 beta into P is alpha beta, and beta minus 3 gamma into P is equal to 2 beta gamma. From here, you can plan to find alpha and gamma in terms of P and beta, right? So let's plan out. From the first one, since the first equation simply says alpha minus 2 beta multiplied with P is equal to product alpha beta, right? So from here we can find alpha is equal to 2 beta P divided by P minus beta. Clear on this point? What I have done, taking it on the other side and taking alpha beta on the left hand side. Next, what is given next? Let's check out the other. Beta minus 3 gamma multiplied with P is equal to the right hand side 2 beta gamma. So here you can find gamma as, taking it on the other side, you are left with beta P divided by 2 beta plus 3 P. Correct? This is gamma. Now put this value of alpha and gamma in this equation, say 1. Put alpha and gamma in, say, 1, right? Now 1 is alpha upon p plus alpha. So p b1 upon p b3 is equal to alpha. What is the value for alpha? 2 beta p upon p minus beta. Alpha upon p plus alpha. So write here upon p plus alpha. Multiplied with, next, what is there? This is p plus gamma upon gamma. So p plus gamma, that is beta p upon 2 beta plus 3p divided by beta p upon 2 beta plus 3p. Clear on it? Just try to simplify and see what we are getting. We can see that p is cancelled from both the factors, right? We are left with 2 beta divided by, take here LCM, this is p minus beta plus beta, that is p plus beta, multiplied by. Here when you take LCM, this is 2 beta plus beta, that is 3 beta plus 3p divided by beta. Now here I can see that this beta is cancelled, p plus b is cancelled. What is the result finally? That's the value 6. So here we obtained the answer for this question as 6. So let's write down the required result is 6. So I'm sure this is clear. Let's take up the next one, question number 6. If the least and largest real values of alpha for which the given equation has a solution are p and q respectively, we have to find the value of 4 times p square plus q square. So when you consider z as x plus iota y and substitute it here, you can equate real and imaginary parts. So this is x plus iota y plus alpha root of x minus 1 whole square plus y square plus 2 iota is equal to 0. Equating real and imaginary parts, what we will be getting? We simply get y plus 2 is equal to 0 and x plus alpha times root x minus 1 whole square plus y square is equal to 0. Clear on it? So here we get y as minus 2 and just try to simplify it. For this purpose, let's take x on the other side, square upon each one. So we are getting x square is equal to alpha square multiplied with x square minus 2x plus 1 plus y square is simply 4. Correct? So here we are getting a quadratic equation in x. Let's write it. X square times alpha square minus 1 minus 2 alpha square x plus 5 alpha square is equal to 0. So this is the quadratic equation we are getting. If you talk about discriminant of it, this is obtained as 4 alpha 4 minus 4 into 5 alpha square into alpha square minus 1. It should be greater than or equal to 0 for some real solutions. So we can take this 4 common and just throw it to the other side. Now we are left with alpha 4 minus this term. Let's take alpha square common and take minus sign common and throw it to the other side. So what we are left with? 5 alpha square minus alpha square giving you 4 alpha square minus 5 less than or equal to 0. Now we can simply conclude here that the minimum value of alpha is minus root 5 by 2 and maximum value of alpha is root 5 by 2. Some extra roots are also obtained because of the square, but you can see on verification that those are not forming the required things. So the correct answer 4 times p square plus q square as required. So just write down 4 times p square plus q square is equal to 10. So let's write this as the final answer. It is 10. So I'm sure this is also clear. Now time to move on to the next question.